So thanks everyone for joining today for our discussion and expert Q&A on HVAC opportunities. As we're about to dive in here, since we will be tackling some of the questions that you submitted or questions you have, before we get into those questions or unsolved problems, I'd really like to take just like 2 minutes here to hear about some successes you have had with HVAC, and whether that is figuring out some issue that was going on, or a project that got installed, or even just getting some buy-in or support from people to look at HVAC and the energy that's being used in your HVAC system. Would love to hear about those from your participants. So you can annotate directly on the screen. We have space on the screen to do so. If you go to the top of your screen, there should be a menu that pops up, and if you go to view options and click annotate, there are some text options within that, or you can open the chat and type directly into the chat. Later on, we will be using the chat to solicit any questions you may have as well, so good practice of entering some of that in here. So I will give everyone just a minute or two to get some wins up there and see what some people may have been working on. Oh, great results from a recommissioning project, 23% energy reduction in the HVAC system. That is awesome. And we have from Nick, preventative maintenance, buy-in to extend equipment serviceable life. That's great. Always, I've heard some organizations that see the value in preventive maintenance, but sometimes have trouble mustering those initial resources and get away from firefighting. So that's excellent. That's a great move. And Benjamin has recommissioning progress at 18 schools. Excellent. Oh, and Nick has great results from the preventive maintenance, 25% reduction in repair maintenance costs. Great to hear.
I would say that the energy that's used inefficiently goes to destroy or damage the system. That's fugitive energy. No, it's a reality, right?
So it's not just wasting energy; it's using that energy against you.
Well, no. What happens is it does, yeah, because in so many ways, like vibration, heat, noise, all that kind of stuff, like extra pressure on seals and pumps, like all of that stuff can be dealt with through obviously the right measures for efficiency, and it helps the systems.
Nick, have you normalized or corrected or done your non-routine adjustments on your data to correct for COVID? You don't have to answer that. I'm just.
We do see the chat. Well,
I'm just teasing you because we were talking about doing that earlier. But that's still a to-do for us.
And Robert Smith's seen some school boards using ECMs to replace the older motors. That's great. All right, it's really great hearing about these successes that are already happening there. We know that within HVAC there is a lot of opportunities, so great to see the work that's been going on. And today what we're going to be looking at is opportunities within HVAC systems. And I'm joined today by two industry experts that many of you probably already know. We have Stephen Dixon from TDS Dixon and Michel from Technosim. So thank you for joining us today. And what our main focus is going to be on is we'll start off today with sort of an interview. So with Olga, the energy manager for Canadian Tire, and have a bit of discussion with Stephen and Michel, addressing some of her questions and using that as sort of an example of working through, how do you think about your HVAC systems and where to find opportunities and what those opportunities may be. We'll go from there into a brief overview of a general approach to improving HVAC efficiency, and how do you look at your HVAC systems? How do you approach them if you are looking to optimize and find efficiencies within those systems? And then the last item, which we are looking to spend the bulk of the time on today, is expert Q&A. So thank you everyone who, when registering, submitted those questions. We have those questions prepared. We're going to get to those. If anyone else has questions or other questions you'd like to ask, please put them into the chat. We'll get to as many of them as we can, and those ones that we can't, we'll look at following up afterwards. All right, so I think we're about ready to dive in. And Olga, if you're online, oh, I do see you online. If you can unmute. Olga Horolskaya has been kind enough to join us. She's a very experienced energy manager from Canadian Tire. She has won the Save on Energy Manager of the Year award for 2019. And thank you for joining us today for this little Q&A interview. And I think you may still need to, have you, you're unmuted there. Can we hear you?
She may have to select a different microphone.
Okay. Yeah, Olga, we can't quite hear you yet. You may need to select a different microphone from the toolbar, the microphone toolbar on the bottom left. Helen, can you put in the phone number as well? But we can get in there. So while Olga is looking to connect with the audio, so we
can you hear me?
Oh, there we go. Excellent.
I think I'm unconscious IT hacker. I'm joking.
All right.
Guys, thank you very much for your comments. I'm glad to present at this webinar, and I'm glad that my questions were selected just for discussion. And I'm very curious to learn more about the HVAC, because I think that the HVAC has a great potential. I think it's almost like up to 30% on savings on energy bill. So it's a great thing for energy managers to consider. And can I start with my questions?
Sure. I think I've got a few up on the screen here that were around. You know, I know you have a large number of facilities that you're dealing with. So I think you had some questions around how do you look at all that data that you have to find some insights of where to look, right?
Yes, absolutely. Canadian Tire, as you know, we have like more than 500, I guess, stores, big stores, CTR stores, but it's dealership model. But we have lots of banners, and you can see them on a page. It's SportCheck, Marks, National Sports, Hockey Life, Atmosphere, Part Source. And all the stores, like just Marks, it's more than 400 locations across Canada. And that's why I would be very interested to learn from you on opportunity how to determine this savings for the large portfolio in small retail stores.
Mm-hmm.
Well, I was really excited when I saw that question, Olga, because we've done quite a bit of stuff like this before, and I thank you for all the questions you sent. You kind of inspired us to have this session at the beginning, and so it reminded me of a couple of situations that I had. Actually, I'm going to get you to go to the next slide first. In fact, when I do benchmarking, I like to look beyond the overall benchmark. A lot of people, when they do benchmarking, take the total energy intensity, the kilowatt hours per square meter per year. So they take all their electricity, all their natural gas, and the other fuels, they resolve them all to kilowatt hours, and then divide by their floor area. So in this chart, the far right-hand column is the total energy intensity. And that can tell us something. But I like to dig deeper. So what I like to do is I like to calculate, in addition to energy intensity, water intensity. Because now in your stores, that may or may not be a factor. You know, large, as you said, a large amount of your energy is HVAC. But in other situations, water can be quite a dramatic, like if you've got multi-unit residential buildings, understanding, you know, water or energy follows water. In manufacturing and food, energy follows water, right? You got to heat, cool it, treat it, whatever. So having water in there is important as well. But on the energy side, I like to do demand intensity, the watts per square meter of the facility, the electrical intensity, just the electricity, and then the heating energy intensity as separate indicators as well. And then by stacking up, and the virtue that you have in your situation, even though you have all those banners and those brands out there, you have a lot of similarity. Any one of those brands, those stores are going to be very similar to one another. So doing benchmarking between them becomes actually really, really valuable from that point of view. So overall, I would say, yeah, benchmarking within a group. But if you back up one slide there, Jay, the one thing I want to point out is that by looking at this demand and electrical energy and natural gas energy intensity separately, you can actually find things. So in this example, this is an office building, but it could very well be one of your stores, right? I just didn't have the data for your stores. So, the range for a particular office building for the demand intensity was 4 to 10. I had this one building where they called me and said, should I do an energy audit? I said, I don't know, but give me your data. So I did this, 6.7. So they're right in the middle of the range. The natural gas intensity, same thing, right in the middle of the range, 12 to 24, 16.9. Those are why they're green. The electrical energy intensity was out of range, right? 14 to 26. That's a pretty wide range. You go, well, how can I tell anything from that? And they're, compared to Boma Bast or RealPac, they're way up there, right? But we could tell a lot about this building based on that electrical energy intensity. And it turns out that when I started to question them, and you can think about what's the difference between demand and energy when it comes to electricity? Time. This red indicator here, the 30.6, was an indicator systems were running longer than they needed to. And what it was they had an office building with an operations center on 1/4 of one floor. They were running the whole HVAC system to meet the requirements of that one small, 1/16th of the floor area of the building. Putting in a satellite system, they brought themselves right back into the middle of the range. So we were actually able to estimate that if they brought themselves back to 20, they would save 10 kilowatt hours per square foot per year. From that, we estimated the savings, and we came within about 10% of what they actually saved when they implemented that. So there's a way to take a lot, sort of billing data, and you can do it on a portfolio basis too, but billing data individually in the building and start to see opportunities. I hadn't even gone to that building and I was able to find that opportunity. Now, the other thing I'd like to point out is because one of your questions referred to, I think, the idea of interval data, right? What can you do with interval data? Well, you can do amazing things with interval data. I've always said there's always an opportunity in a demand profile, right? So a demand profile is on slide 9. Jay's going to flip over to slide 9. But for Olga, for you to go and look at all your stores, all the demand profiles, that's a lot of work, right? That's a lot of work. How can you get an idea of what your demand profile looks like without actually going to the store or looking at the interval data itself to begin with? Well, that's where I use a thing called load factor. Back a slide here, Jay. So load factor actually speaks to the shape of the demand profile, because the load factor represents how much energy you used compared to what you would have used had you been at your peak demand all the time. So if you've got a very low load factor, it means you have a very spiky demand profile in most cases. If you have a very high load factor, it means that you're using energy at a high rate all the time. And even month over month, we can look at buildings and say, okay, this building through the lower graph there, the load factor graph, most of the months it's between 41 and 45% load factor. There's 2 months there, October and May, where it's out of that range. So that's what I would go ask the question, what's different about those months? And if I saw buildings that were very erratic in their load factor, especially Olga, in your case, because you have a lot of buildings that are very similar schedules, similar patterns of operation, the load factor is very dependent on the pattern of operation. So you can figure out which ones are anomalies by looking at the load factor overall, month by month or even on an annual basis. So there's another tool, load factor, to look at a portfolio of buildings.
And just for everybody to be very clear on that, when you use load factor, is excellent. It's an excellent indicator when your buildings are very similar and use the same type of heating. So Olga, if you have buildings, for example, that are located in Quebec and they're electrically heated, you got to be very careful about using load factor for those stores and comparing them to stores located, let's say, in Ontario that may have a different profile. So it's very good once you know that you have a fairly
homogeneous.
Yeah, exactly. Yep.
But if you've got a large stack of
compare apples to apples, right?
Yeah. But you've got lots of apples in any one of your baskets. So that's why I think it's going to work well for you.
Thank you.
So there was some, and I'm always a fan of interval data. If you've not got interval data, go out and get it. You can see so much. I remember Canadian Tire Store years ago where we metered it. We didn't even have interval data, but we metered it with a power meter. And we actually ended up identifying 50 kilowatts of electric heat in a warehouse area that was coming on in the summer on a cold morning, once a month, hitting their peak demand, right? And that would, that's not necessarily going to generate peak demand savings in the sense in Ontario. But on the other hand, those are things you need to be aware of, right? So there's always an opportunity in interval data if you've never seen it before. I promise you. That's my experience anyway. All
yes,
right.
for sure.
So where we got some more of the questions here. What are the main opportunities? Yeah, go ahead, Jerry.
So Olga, you also had some questions about, kind of general opportunities within the HVAC systems in your stores, and what are some of the key things to look for in terms of improving efficiency without impacting comfort, and those kind of low cost, quick wins that are around there.
So one of the things that I like to think about, and I know that Michel will sort of move into this too when he touches on the basics section. We go to the next slide there. And Olga, do you want to add anything to those questions as we go, or you're good for me there?
Yes, please go ahead.
Okay. So I always like to think in terms of what are we trying to manage, which drives energy consumption, right? And Michel, time is the first one, right? That's the biggest opportunity we're going to find, right? Time.
Yeah, and it might seem very simple, might seem something that most people will be doing, but I guarantee in most of your facilities, there will be opportunities related to time, scheduling. Yeah. Maybe trivial, but those trivial items, when you do recommissioning, and we've seen some wins from recommissioning, over and over again, Stephen, we see that it goes back to time.
So if energy is power times time, then power in this case relates to temperature, flow, and pressure as well. So when you think about it, these are the things you have to think about, right? So you're looking for ways to somehow reduce while still maintaining conditions, and Michel will speak to that one, the time, the temperature, the flow, the pressure, right? I mean, pressure drop from filters, right? Somebody talked about parallel pumps. There's a great one, right? So there you've got two pumps that are not actually making efficiency in parallel. So I always like to think in terms of time, temperature, flow, and pressure. What are we doing which impacts those things, and how can we change that, right? So certainly on the next slide we talk about temperature control, and I know this is boring stuff in many ways, but there's in some ways, I think a lot of HVAC savings aren't exotic. They are actually very, very basic in principle. And we need to pay attention to those basic things because that's what's actually going to deliver some significant results. Michel, you're going to say something there.
Yeah, because I've done a lot of work like in your field, in the retail sector. And the one thing when I was doing benchmarking, and that applies to actually any building, I always look at the summer load of, let's say, natural gas. And a lot of the stores would have only, let's say, water heaters. Sometimes they have no summer gas usage. They have no load, but you still see summer consumption. And that is related to proper temperature control and obviously disabling the heating. But I was doing audits in the retail sector last week. And what did I find? Natural gas usage in the middle of the summer when the only thing they have is natural gas heating. They don't have any domestic hot water. So when looking at benchmarking, you can actually look at the base load, which is what are you using either for electricity in the winter or for gas in the summer. And that can give you a lot of clues to where things are not going right. And very often it's due to temperature control.
Yeah, dead bands, not set right, different ways that simultaneous heating and cooling occurs. And actually in your stores, one thing I've seen over too, you've got thermostats on posts in different zones. You've got like kind of open zones in stores. So making sure your thermostats are synchronized properly, that can be an issue as well. I've seen, units, side by side almost fighting one another. So Michel, have you run into that? I'd certainly run into that in manufacturing where you've got a large open area. You might have 10 rooftop units, each of them on a thermostat on a pillar or column somewhere. And those units are not isolated from one another, and they will interact.
Yeah, it's quite common. I've seen some really bad cases where the thermostat were not locked. It was in restaurants, actually, a restaurant chain. And some people could actually, the public could actually change some of the settings. And you had heating, you had cooling, you had the free cooling, you had all kind of possible.
$6,000 an hour.
Cool. Okay, any thoughts, any comments? We got some ideas here.
Guys, sorry, I might quote you on a site, but do you have, because we have lots of stores, right? I know that some stores, they have stratification funds and some are not. So what is the business case? What is the kind of payback, like simple payback for installing such funds?
Actually, yeah, we can go to the next slide there. I actually found a case study from a Canadian Tire store. I didn't hope I didn't spring this one on you. This was actually from the manufacturer of one of these destratification fans, and they had a picture, and they actually had some quotes from a manager, owner manager of a Canadian Tire store. There are some opportunities, and it's an interesting one. We often use this when in our training for RETScreen. We ask the question, how does RETScreen calculate savings, or how can you use RETScreen to calculate savings for destratification fans? And people will go searching through RETScreen for a destratification fan model and not find it. And ultimately, the answer comes down to understanding how the energy consumption of the building is affected by destratifying the air. So it's really, where is the energy lost or gained from the building? So in the winter, there is a case, I suspect, I mean, it will depend on the situation and the level of stratification for reducing the temperature at the ceiling and, in this case, in the roof, right, which is right above that. You're reducing the heat loss through the upper part of the building. Now, some people will try to tell you that it's about how the warm air coming down satisfy the thermostats. Well, that's kind of an indirect thing, but it's really about the heat not being lost from the roof of the building. Now, the summer situation, right? That's an interesting one, because Michel, you can speak to this one too. There is a method of cooling large spaces called stratification cooling, where you cool the first, say, 8 to 10 feet, and then you leave the next 10 to 15 feet in the high bay space not cooled. And because of the fact you've got this warm air up there, it stays up there, right? And it's like an insulating layer between, the cooled space and actually the ceiling itself. And then there's another technique called displacement cooling, correct, Michel?
Yeah, and that's the basis of displacement ventilation, is the same as like stratifying, benefiting from that stratification, which applies in the summertime, obviously. So these for reducing your peak demand, for example, is usually a doubtful proposal. Is really good in heating. It can be counterproductive energy-wise in cooling. It can improve comfort when you don't have cooling. We talked about that with Jay. Yeah. But you have to be very careful about claiming savings for cooling, or demand savings even more with these strat fans.
Yeah. So one of the things that really brings into play, especially when I described that idea of having the stratification, which can actually sort of enhance your cooling or efficiency, is understanding the systems, how your systems are designed to operate. And Michel will speak to that one in a few minutes. I think before you change any system, it's always good to understand exactly how it works and why it operates in the way it does now. And then, because I've often seen people go in and modify systems and actually, as Michel would say, make them worse, right? So sometimes those changes can be counterproductive. So your question is really good. We do have to understand, what is going to be the impact summer, what is going to be the impact winter. And as I'll agree with Michel that you're going to see a far more positive impact, albeit on a lesser costly form of energy in natural gas, potentially, or could be electricity in the winter, depending on how you heat. So does that help, Olga?
Yes, absolutely, guys. Thank you.
Okay. And there was one other question you had about thermostats, and does the thermostat location play a role in operational efficiency? And I'm going to say, what do you think, Michel? I'm going to go with 100% yes. So
yeah, absolutely. Yeah.
like there are places to put a thermostat and places not to. That middle picture there actually kind of violates all the rules. You got a thermostat sitting over top of a microwave, a coffee maker, a fridge, and on the right-hand side is the doorway, which could be influencing it. So, and those, one of the biggest problems with thermostat placement is interference from other sources of heat or airflows or things like that, or not being representative of the space that you're actually trying to condition themselves. The one on the left, you got a printer sitting there. What's interesting is sometimes a revolving door, Nick says, yeah, absolutely. I've actually, remote sensors are a great way to get better space temperature if you need centrally locate your thermostats. Yeah, that's right, Nick, absolutely. So yeah, we do have to be careful. And I talked about in your stores on the columns, the thermostats, right? So actually we just had a Vern came in. Stephen, regarding your comment concerning stratification where the hot air has risen into the top part of the space, would it not be more efficient just to clear that hot air out with fans once the evening temperature is cool enough? Yeah, I mean, I have to think the answer to that one through. That's probably not a bad idea. Kind of like a purge cycle in the building. But when you say clear it out, you got to replace that air with something coming from somewhere. And if it's warm and humid outside, you could actually be sort of shooting yourself in the foot on that one. Michel, do you want to?
Yeah, I've done some evaluations of that. Some people that try to cool their building at night with running the fans when the air is cool outside, they actually end up spending more electricity running their mechanical cooling because of how efficient mechanical coolings are and how relatively inefficient the fans are. You've got natural ventilation. It is a great measure. If you can open something at the top of the building and obviously at the lower portion of the building and get that fresh air to flow freely through your building, it's really good. Or if you have variable speed fans and you can run them at low velocity, but if you use your standard HVAC to cool the building with outside air, you often will actually spend more with fan power than you would have with the actual mechanical cooling in the daytime. As for the distrat fan, you would need to have some opening. You could use distrat fans to evacuate that heat once, during the nighttime. But again, you would need to have some form of opening to let that warm air go out.
Good point. Yeah. So again, you've got to understand your systems, and I'm always going to caution taking in outside air. If there's more moisture in it than there is in the inside air, then you're going to cost yourself in potentially dehumidification or moisture removal through your air conditioning later as well. So you'll always have to be careful. Even though the outside air feels cooler, it could still have more energy in it. Correct, Michel? Yeah. Okay. So.
And Olga, I think you had a couple of questions about specific sort of new innovative opportunities that you were looking into.
Yes, guys. So if you could explain on some cost-effective options available on the market to automate operation, because say with the stores, we want our stores to focus on sales rather than keep in mind how operational HVAC issues, right? So it would be good to understand whether on the market any opportunities.
Yeah, and I think specifically, like Canadian Tire has been looking at sort of new switch reluctance motors and new smart control systems. Is that part of it, Olga?
You know what? Of course, in industry we have kind of different. We hear about different technologies, right? I cannot tell what Canadian Tire is doing, right? It's confidential information, but of course, I guess everyone nowadays familiar with such technologies like turn-timed motors or new kind of virtual EMS systems, which in cycle with swarm stats kind of represent this group. So that's I have questions about this because I'm very curious energy manager.
Who's going to jump on this one? I guess I am. Well, I think the key thing in all of this is really again, to understand what the particular technology is trying to do. And I think that there probably are some relationships between, I mean, you talked about a couple of, advanced control technologies here and motors that are more efficient and for which you can change the speed. And obviously, I mean, there might be some interaction between those types of things. So I think it really comes down to, what are you trying to, like, what are your systems designed to do? What are you trying to achieve with some of these devices? I'm always a little bit concerned about sort of blanket efficiency or blanket improvement numbers when they come out. And again, I think the interaction between things, because if you've got a system which has the ability right now to operate at various speeds or variable speed, and you add control to that, how much can you improve upon that? So my concern would be, and it's hard for us to. Patrick is asking is Olga referring to speed control based on occupancy? Is that one of the things that you would talk about? You're looking at those motors would change the speed of that system, right, in order to vary rates of ventilation and airflow.
Sorry, Stefan, is it a question for me?
Yeah. Yes. Yeah.
I cannot answer on it honestly, because I'm not kind of so much involved in turntide. So I would I'm just asking it on a general sense, right?
Okay.
So,
so
because your question is more kind of detailed on specific operations, right? And I honestly cannot answer it at this time.
So Michel, do you have some thoughts at a generic level on these things?
Yes. First thing I want to mention about the motors, the switch reluctance motors, those high efficiency, they're DC basically motors, a bit ECM. And you have to be very careful. You don't get the bulk of your saving from the motors, because the motor itself is usually, if we talk about where those type of systems go, they go on relatively small rooftop units. Motor power is not the biggest consumption item. It's really because if you can reduce the flow, as we know, the power varies with the cube of the flow. So it's the variable speed option that really gets you the savings, not purely the efficiency of the motor, the improvement in actual efficiency. So if you can get let's say you don't want to change the motor and you can actually, it's easy now to install a small drive, even on a 1 horsepower, and you can actually put that on a motor, you will get similar benefits. So you don't have to go to a specialized motor. If you will get similar savings by having a small VFD. And as far as the smart thermostat, we talked about that, Stephen, just before. It's only as smart as the people that are going to use it. Do not rely solely on technology. Biggest mistake anyone can make is say, I'm installing AI in my building and I'm good to go. I'm not going to look after it anymore. Big mistake. AI is only as good as you will make it. And Olga, you probably look after your storage or an energy manager, but not an install and forget measure. If you do, I've had a case last week where they had, it was not that brand, very similar, and the fans are running 24/7 because somebody decided to put an override and they're relying on the fact that it's a smart system. It's not that smart. So you gotta keep an eye on your smart system. Otherwise, it will use very often more energy than before. That's my little take on that one, Steve.
No, I agree. That's what I was kind of. Yeah, and the other thing too is, like, one of your questions I think also dealt with the interactions between these systems too, and very much so the control and what's being controlled, right? And then the systems that the motor is then serving, they all work together. So I can almost guarantee you that if you added up all the percentages that each of these things claim individually, you're not going to get that overall percentage. It's going to be some combination, which you really have to go back to first principles to estimate. So I guess we're encouraging caution, right?
Yeah. All right. So thank you very much, Olga, for your questions, and Michelle, Stephen, for your responses on there. Graham did have a question about the switch reluctance motors and if there's any benefits in terms of reliability benefits versus VFDs. So, Michelle, Stephen, I don't know if I'm going to quickly go into the next section if you want to respond in the chat on there, if you have any insights regarding of what might be some differences between those.
No, I would have to. No, I don't. I can't really speak to that. So, Michelle.
All right. But yeah, you can feel free to enter into the chat there if you have any insights related to that. We did send just this morning with a reminder some slides on, HVAC system basics, and we're going to skip over. We're not going to cover them in today's lesson, other than to say that it is really important when you are starting to look for efficiencies in your HVAC system to really understand, what is the purpose of that HVAC system, maintaining comfort, ventilation, air quality, removing contaminants or heat gains, and understanding the function of how it is working to achieve those goals, and having that kind of understanding as a starting point before looking into where those opportunities may lie.
And before you jump in there, Michelle, I just want to thank Olga for her questions. I know we went pretty hard on those, but thank you very much for those.
You're very welcome, guys. I hope it helped other energy managers to answer their questions, because I received answers today, and I will go with it. Right?
Yeah. So just
Thank you.
what you said, Jay. Even though it's called HVAC, you guys got that. A lot of people tend to assume that the ventilation system, regardless of its type, will do all of the above, all of the HVAC portion, which is not true. And that's where the time component that we talked with Stephen actually still has opportunity almost everywhere, because a lot of the systems we deal with, for example, do not provide heating. Makeup air units don't provide heating typically. They preheat the outside air, but they actually are not a heating system, because if you use that as a heating system, it'd be the worst type of heating system you could decide to design. Most VAV systems are not heating systems. Makeup air unit are not really, they're filtration, but not for the interior air. So they have different role. Once you start, let's say you do your self-evaluation of your HVAC system, it may seem very trivial, but you need to understand what is the role of that system. So, there's no need to start a makeup air unit 2 hours before occupancy, because they're not heating. So it's in the middle of winter, don't start your makeup air unit at 5. If people come in at 7, you can start it at 7. A lot of VAV systems in the heating mode, let's say you're in the middle of winter, there's not very many internal zone, no need to start that early. That's where you can get easy wins. You say, hey, I'm starting those systems way early. I was doing audits last week. They have VAVs, they start them at like 3 in the morning in the winter. I'm like, why? Why do you do this? It's not, well, they say we need a heating. They've got baseboard. The baseboards are supposed to be doing the heating. So make sure you go through your system, you make sure you understand their role, and then have clear target. We talked with Olga, Canadian Tires, and all the different stores that they have very clear target. You cannot optimize your HVAC systems if you don't have target. It's like trying to shoot a bow and arrow without a target. You'll never get the bullseye. So you need what's called CFRs. What am I supposed to meet? And then I'm going to optimize my system to meet those requirements. So really 2 key pieces here. Make sure you understand what are the role of your systems, and then have clear targets. Then you can optimize. That would be it for that little portion that you guys did this morning.
Great. Yeah, and I think that's a really great point of that starting point of understanding, what are your facility's requirements. And I think that's like the first step in any recommissioning, but even when you're even just starting to think about your HVAC systems and planning out where those opportunities may lie.
And that also speaks back to Olga's question about not compromising comfort, right? And if you can hold, if you don't have a CFR, then by establishing one, then you develop a relationship with the users of the space too, right? And then it's understood that you're not there to compromise anything. You're there, in fact, to enhance it.
And we have a sample one here. This will be included. We will send out the slides following the workshop if you want to take a closer look at it. But then what I want to touch on a little bit is, you mentioned that CFR is kind of that first step in recommissioning. So if you want to touch briefly on that recommissioning process, which I think is important to understand. We heard it at the beginning with the wins, some of the great benefits people have gotten from going through formal recommissioning. But I think this process is also something that if you're not going through that formal process, but just starting to look and understand and find opportunities within your HVAC system, you'd follow these similar steps.
Yeah, the one thing to remember about EBCX, it's not an energy efficiency measure. I know we're talking about energy efficiency. It is not. So don't fall for a trap saying I'm going to sell you an EBCX and it'll be for efficient energy efficiency. It is not. It is to optimize your systems to meet your CFR. And usually 99% of the time you will get really good savings, but it should not be the end goal. The end goal is to ensure, either if you're industrial, that your production will be improved. If you're in a commercial, institutional, that the quality of the building for the occupants will be improved, and that will typically result in energy savings. So if you could go down the road of EBCX, also make sure you follow a structured approach. If you have not heard about the CSA standard, there is the Z5001 standard. So if you've never done an EBCX, very good idea to go along with that standards. Otherwise, it's very easy to get sold kind of an energy audit that is being stamped as a recommissioning. So kind of a word of warning about doing it the proper way. It's the standard is the CSA Z5001 or EBCX.
Okay. All right. And then, so I think that's a great place to start for everyone to get that understanding of it. We actually have, I do want to announce that we're doing an Ask Me Anything. So University Health Network recently completed this spring 2 large recommissioning projects at 2 of the hospitals in Toronto. And Mehdi, one of the energy managers from UHN, has been kind enough to offer to the community to ask him anything about the projects, the results, energy management at UHN. So I really would encourage people to go on to the Energy Manager Learning Platform. Helen will put the link into the chat for it. And on the forum, in the general discussion, you can find a thread where there's some information. There's links to the case studies on these, really detailed case studies that show, the work that was done, the challenges they overcame, and the results that they achieved. So take a look at those case studies, and then in that thread, any questions that you have about them that you'd like to learn more, post those questions, and then on August 10th, Mehdi will be going through the questions that were submitted and providing responses along with his team at UHN. So thank you, Mehdi, for doing that. I believe you're on the line now, so thank you for offering to that. I'd like to jump in right now for the expert Q&A. So we had some questions submitted with the registration, so we'll start with those, and then I've seen a number pop up in the chat as well. We may not have time to get to all of them. The ones that we don't, we'll follow up on the forum with responses as appropriate. But to get kind of started on that, we had a few questions from energy managers around finding opportunities. So this was, how do we go about surveying the internal HVAC system, what to look for in that assessment, what are recommendations that we can do to optimize HVAC systems, and if they do find one building using more gas than others of a similar size through that benchmarking process, what are the first things to look at? Now, I think with the questions with Olga and some of this overview of the EBCX process, we've kind of covered some of this, but is there anything particular you'd like to highlight in response to these questions?
Sorry. Do you want to restate, is it the first question, the one about doing your own estimation, your own energy about it, basically?
Yeah, so like when they start looking or surveying their HVAC system, is there anything in particular that they should be looking for in that assessment?
Well, yeah, you see, start with the big ones. It's a kind of silly answer. But then it's runtime first, and you gotta go and visually inspect. Don't rely, if you have a BAS and you say, I'm gonna look at my systems, and do not trust the BAS until proven that you're wrong. So I always say the biggest liar in the building is the control system until proven otherwise. So you have to go up there, open the outside air damper section, the filter section, when the system is supposed to be in minimum outside air, such as now. It's warm outside, go in your air handling unit, open the filter section, check where those dampers are set. And because how long do they run? So you need to know the type of system, how much outside air is being brought into your building. Is it too much? Is it not enough? And do not rely on damper position to give you the amount of fresh air. Dampers are really nonlinear, sometimes extremely nonlinear. So you gotta have an idea of how much they're open, and then maybe either using temperature or a flow meter, or temperature is probably easier, get an estimate of how much is actually being brought to your building. So, you know, it's really runtime, and obviously check how cold or how warm you're supplying that air to your building. That's where I would start. Sorry, it's a very long answer.
No, that's great. We also had a couple of questions from Jensen and Robert about if there are any novel, innovative equipment approaches in HVAC that they should be looking at in terms of new things in terms of opportunities for heating, cooling.
Well, I'd say there isn't very many new ones. I mean, the AI is taking more and more room. We talk about the AI. It's good. It does provide diagnostic, as somebody mentioned. But again, don't leave the AI or what we call fault detection diagnostic on its own. It is a tool in your toolbox. Then there's the really old solution coming back in fashion because people want to decarbonize their buildings. So start looking again at heat pumps, low temperature heat pumps. They're not for large application yet. Heat recovery chillers, depending on your application. Heat recovery chillers have been in many buildings where they were removed in the 90s, and now they're putting them back in because that is a low carbon heating source. So in terms of new technologies, yeah, there's variable refrigerant flow system, which can be low temperature heat pumps at the same time. They do have drawback. A lot of refrigerant goes into those systems, but I'd say in terms of new technology, it's not that new, by the way. It's probably at least 10 years old, if not more. But that's probably one of the few newer one, what we call VRV or VRF, variable refrigerant volume or variable refrigerant flow.
Yeah, I think there was a question about heat recovery chillers, and that kind of relates to what you just said there, because the heat recovery chiller operates with a heat source that's relatively high temperature. Therefore, the lift on the chiller is relatively low and can then be very efficient. And I agree, Michel, what you said. I think probably there's a lot of not controversy, but a lot of people are a little leery of them. But the VRF, the 3-pipe systems where you can actually have heat pumps running heating cooling mode, and you can recover heat within the system, that could be pretty, that could hold some pretty good promise. But it's a complex system, and it requires some pretty specialized expertise in terms of design, installation, and maintenance. So,
and the long-term maintenance may become an issue because you end up with a lot of refrigerant and a lot of like fan coil, basically, in all the zones.
Yeah.
All right. We had some other questions around, evaluating opportunities within HVAC systems. So, we had a question from Paul about how do you estimate savings for nighttime setbacks or unoccupied setbacks. And there's a few others I'll get into, but maybe like touching on that one too. There are some others talking about, how do you evaluate savings of reducing outdoor air percentage, or just in general on these HVAC measures? What's the best way to sort of quantify and calculate those savings?
Yeah, there's really two sides to that answer. One is, how do you estimate the savings up front? And then how do you measure the savings down the road, actually, when you implement stuff? And that's called evaluation or measurement verification. In terms of the upfront calculations, if you've not got complex HVAC systems, then Red Screen does a pretty good job of looking at temperature setbacks and even ventilation rates. As long as you understand what the ventilation rates are, Red Screen has a nice little calculator in there. Now, if you're into a complex HVAC system, I'm pretty sure that, Michelle, you would turn your attention to eQuest or another hourly simulation where it's a bit more complicated, correct?
Yeah, when you want rules of thumbs, I would go Red Screen, because, yeah, if you want to go with eQuest, it's quite a bit more costly. And very often for high level, you're better off with Red Screen.
Yeah, and when it comes to measurement and verification, option C, Red Screen, I think is pretty powerful. It has a pretty good suite of tools. There's probably a few things that it can't do, as any tool can't do. But on the other hand, it's the tool of choice, I think, for an option C for most folks, especially when your savings are above 5% overall, 5 to 10.
Oh, so,
so for those who aren't familiar, the option C is sort of the full building energy model that's normalized against weather, so you can see the efficiency improvements regardless of weather changes. Is there, for instances where option C may not be appropriate because the savings are smaller, or it's in, say, an industrial facility that's not heavily weather dominated in terms of the facility energy use, what's sort of the main recommendation there?
Well, I think in that case, you're into A or B, or method A or B, which is isolation or partially.
Yeah, you have no choice but to go with measure isolation. You have to measure at the equipment level itself.
Right. But one thing I won't challenge you on, but I'll kind of counter you on there, Dave, as you said, an industrial facility where there's not a lot of relationship to outside temperature, that may not always be the case, right? And especially on, I think one of the questions was about HVAC and industrial. A lot of times the HVAC systems, industrial, in the office, lab, areas, those things can get neglected a lot, right? And so, my experience is there's lots of opportunity in those, and especially to apply in EBCX as well. And in fact, when it comes to, in general, I think weather can have a huge influence. I remember a case of a pulp and paper mill where they were trying to develop performance models for their paper machine, and they could not get the models to work nicely until they brought into account outside temperature. So at that point, what they discovered was there was a lot of ways that they could isolate the process from the outside conditions and save energy. So, so don't always assume in industry that the process, the production is the strongest driver. I've seen so many times when, in fact, outside temperature could be equally or even a stronger driver. But you're right, it's not the only driver. So.
And we actually did have another question specifically around, opportunities to improve performance in pulp and paper or potentially in other similar industrial facilities.
Yeah, which one was that? Did I answer that? I remember it in there. I'm just trying to find it.
Yeah,
that's right. Yeah, on the HVAC units, I think it's like I said, right? How to improve performance, save energy in HVAC units and pulp and paper, right? And that's, I think, the answer is simple there, is that often those systems are neglected. So doing some basic EBCX on those things could actually lead to some pretty promising savings. Michelle?
Yeah, I would start with something like an EBCX, because through the EBCX in the pulp and paper industry, you may actually be able to identify more, I'd say, capital-intensive measures, especially heat recovery. But before you jump to those, complex measure, the EBCX, from what I've seen in the past in the pulp and paper, is a good way to start. And again, I saw some of the chat. When I say CSA Z5001, I'm not talking about the ISO 50000 here. Just I want to make sure that this is clear. This is the EBCX standard, not the ISO standard.
We had another question from Nick in the comments here. That's an interesting one about in restaurants where they often have interior and exterior spaces open to each other with garage door opening to a patio or things like that. And if there are any strategies to mitigate that energy loss that's happening between a wide open conditioned and unconditioned space, without shutting off the HVAC and impacting the comfort inside, or having like noisy air curtains that may impact the customer experience.
Yeah, that's a chin scratcher for me too, Michel. Yeah,
I mean, once you start opening to the outdoor, you're going to be conditioning the outdoor air. So there is not a million solutions. So you could try to get an air curtain that is not as high velocity. It will lose some of its effectiveness. Otherwise, I mean, you're not going to put the plastic curtain strips to your patio. So there, in my experience, and that's obviously I did not do a research on that one, but there isn't much other that you could, other than turning up the set point for your cooling system when it's open. Instead of trying to keep 74, try to keep 78 or something.
Well, and then if people want to sit outside, then in a sense they're sitting outside. But actually, there was one thought that came to mind there, is that in a restaurant where you can have a significant negative pressure in the dining room because of the fact that the air handling system in the kitchen draws a lot of air from the dining room. That's going to actually cause more air to flow in through that opening that you might have. So
you could try to keep the restaurant neutral.
Yeah, and that will actually potentially enhance also. I mean, you want to have a negative pressure in the kitchen with respect to the dining room so that odors don't flow outwards, but beyond a certain point it's counterproductive. So I would say balancing and having a source of makeup in the kitchen will actually reduce that negative pressure in the dining room. So that may have that could have a sort of a marginal positive effect on that large opening.
Okay, thanks. I think we have time for maybe one or two more questions that we've had come in here. One of them was with respect to ice rinks, and if there are strategies to optimize the dehumidification process within ice rinks.
Well, yeah, it's interesting, Michel. I'm sure you've got some thoughts here too, but it kind of also brings to mind the idea of dehumidification in buildings, because especially in a home, a simple example of a home, your air conditioner isn't necessarily an effective dehumidifier, depending on the ratio of your heat load or you're sensible to your latent load. So having systems that will dehumidify separately. So is the ice surface a good dehumidifying element? Not necessarily. It'll depend on the facility, but there is going to be sort of an optimal balance between removing the moisture from the air using a dehumidifier and removing it on the ice surface. Michel, you've had some experience.
Yeah, usually you want to try to avoid dehumidifying with the ice, even though sometimes it's just not possible because it does impact the ice quality. And the refrigeration system is a poor performer in terms of COP. So if you want to dehumidify, you are way better off dehumidifying DX or desiccant. Desiccant usually is a cheaper source of heating because it's usually natural gas. DX will be more efficient than your ice plant. So in terms of energy efficiency, dehumidifying with a dedicated system is way more efficient because your refrigeration system has a COP of maybe 2. Your DX may have a COP of 3 to 4. So it's twice as much efficient in doing the dehumidification. And you can recover the heat if the interior space, the ice box needs some heating. So yeah, you try to stay away from dehumidifying with the ice. So if you don't have dehumidifier, it's obviously a capital measure, but it will improve both ice quality and it will have energy efficiency gain.
Great. Thank you. I think we're just about up on our time here. So I apologize to people who we didn't get to your questions, that we didn't get to all of them. We will be following up afterwards, both on the Learning Platform forum and directly to address questions that were submitted that we didn't have a chance to get to today. A couple of last housekeeping issues. as I mentioned, we will be following up on that. One, if you could take a minute right now, Helen's going to put the link to our feedback form on this event into the chat. If you could click that, or even with your phone, if you can use the QR code on the screen to go directly to our feedback form. We really do appreciate your feedback to continue to improve these workshops that we have, and that we can meet your needs and provide the best value to you. So if everyone could take a minute, it's a couple of really short questions. It'll take 1 to 2 minutes to fill out. That would be really excellent before I get on to just a couple of last items to wrap up. One of those is to announce that we will have our drop-in office hours. So this is informal virtual get-together to ask questions of ourselves as coaches or of other energy managers that may show up. So we will be having those on August. It's from 1 to 3:30 p.m., but it is drop in when it's convenient, stay for as long or as little as you like to ask any questions that you may have. One last reminder for those that haven't signed up and registered for Energy Manager Support Services, please do so. You can go to our learning platform, and there's an email address that you can link to there. And through that you get access to the forum with the Ask Me Anything with UHN's Energy Manager Medi that we'll be having ongoing now. We'll have the resources from today's workshop put up online there, as well as upcoming events and additional news and community input as well. So please go online and check those out if you are registered, and if you don't have access to that yet, please reach out to us to get that access. And one last question that I want to leave with you, and again, you can respond by annotating onto the screen or in the chat box again, but given what you've heard today and the answers, we covered a lot of different areas on HVAC, but I'm really curious to hear from participants, what is one next step that you're going to take this month to move forward in terms of improving your HVAC efficiencies? So, there's instructions to annotate on the screen. You can, from the drop-down menu that should be at the top of your screen, you can choose view options and annotate to write directly on the white space, or you can share it in the chat. But before you leave, please share with us one thing that you're looking to commit to, one action you're looking to take in the next month to, get started on your HVAC efficiency. And I see some annotations starting there. I think there should be an annotate toolbar that has a text option as well. It looks like it may have defaulted to a drawing note on there. If you want to draw the action that you're going to take, I'd love to see those as well. We appreciate the artistic efforts.
We like Pictionary for HVAC.
Yeah. And as we're seeing some of these commitments and actions that the energy managers are going to take, Stephen, Michel, do you have any last words on this? Thank you very much for your time today, and thank you, Olga, as well, for participating in our Q&A interview. But any last thoughts that you would like to leave us with?
Always be wary of people very large savings.
Yeah, and
demand or energy.
Take that's right, and don't just add all those savings claims together, and because there's going to be interactions. So, which drives us back to understanding what our systems are really doing, and maybe we're already doing some of those fundamental things, right? Because any of those fancy devices at their core do very fundamental things, and if we focus on the fundamentals, I think you'll be in the best position to find the opportunities and debunk the ones that don't work. Yeah, optimize VAV minimum damper settings. It's a good one, right? So check run times. Yeah, we had a couple of building operators that once sat there and compared their VAS schedules and realized that one building was far more overridden than another one, right? So.
I just posted a question in the chat. And I would love it if anybody, especially people who use the Delta IntelliWeb BAS systems, which obviously can have a great impact on your on your HVAC efficiency. If you can let me know, either here or email me afterwards. It's just I've had a question from someone saying like, how do I program or use this thing? Who else uses this kind of system?
I can answer that one. Service New Brunswick and hospitals and schools, they use Delta. I can give you a couple of contacts with people over there. So,
that would be perfect. Yeah.
yeah,
But
they're pretty extensive.
And Patrick, thank you. I would love to know what everybody uses, just in case. Like, we'd have little clubs for the people who use specific BASs, so that, because I really do think that, like, people are more often going to get you to your answer faster than searching for the manual, right? So when other people are asking, like, okay, I have to do this thing with my BAS, what do I do? It would be great to already have knowledge of what people are using. So thanks to everybody who's posting that stuff in the chat. Hey, that's great. Jody's using Delta. Roderick's got Siemens. See, we should start with these clubs. This is a great list we got going on. Thank you.
And Andrew, I'm often asked, what's the best BAS? It's what is it?
He won't answer that question.
It is not a BAS question. Even an old BAS cannot perform a new BAS. It doesn't depend on the machine or the technology. It depends usually on the people using
programmer.
Yeah, the user. Yeah, something you said earlier reminded me of something I've heard where people say a new building is not necessarily more energy efficient, but it is going to be more complicated, right? So you can use that complexity and make it work for you, but often people don't do that.
And that's where EVCX comes in the complex buildings.
Yeah.
All right. Well, thank you everyone for joining us today. Again, please check out the forums where we will be posting responses to questions that we didn't get to, as well as Mehdi's Ask Me Anything. So please go in there, check out those case studies. They really are excellent case studies in terms of the level of detail and showing the results and challenges that they overcame at UHN when doing the recommissioning. And post your questions for him on there. And I think it's a really great opportunity that we have from Mehdi and his team of getting those insights and an opportunity to ask questions of them. So thank you again, everyone, for joining today. Michel, Stephen, a pleasure as always.